Well, hello friends. Welcome back to the program. Today we are going to get back to working on Discord support in Ladybird. We worked on that a bunch last year, and then I just got distracted by all these other things to work on. And somebody asked in my last office hours if we're going to get back to it, and I said yes. So this is getting back to it. Now, I haven't been poking around with this site for a while, so I thought today we could maybe do some profiling and see if we could maybe get started with some lightweight performance work or something like that, because while we've done a ton of work on the web platform features in the last year since I worked on this, we have most likely also introduced various new things that have bad performance and haven't really had a chance to look at those in the context of Discord yet. So let's use call grind on Linux, and actually let me start up CLine so that we have a code editor. So I have a patch actually that I typically use whenever I want to run call grind on Ladybird. So it's just a pretty simple patch that just sets it up so that the web content rendering process is launched inside Valgrind. We should really make this part of of the program entry. I don't know why I haven't been doing that yet. I guess because it's a bit hackish. And let me actually make sure that we also start with instrumentation turned off, and then I'll turn on instrumentation once I have something I want to profile. So generally, this just means that the Ladybird process will run normally, but the web content process will be spawned inside Valgrind, but with instrumentation off, which means that it just kind of emulates the program, but it doesn't collect any profile data yet. So it's reasonably fast, and we could probably load the Discord login page. Okay, so there's a lot of stuff here that's taking time, actually. Did you get stuck? No, maybe not. Okay. Yeah, so we definitely have an issue here where it's kind of loading a lot of JavaScript when you open Discord. And for whatever reason, it seems like we don't discover all the resources we need to load immediately, but instead we sort of gradually discover, oh, I need that JavaScript file. Oh, I need that JavaScript file. So we keep having to load more stuff, and it gets kind of staggered out. And I'm not exactly sure what mechanism we're missing for that. Probably we need some kind of speculative look ahead thing, like either HTML preload scanner for the JavaScript. I would imagine that we need to maybe look ahead a little bit. Or maybe these are all inserted by JavaScript and we just need to be smarter about something or faster about something. Who knows? But this definitely deserves some analysis, but it's an old problem that we've always had. Really, the thing I'm interested in is this kind of performance. It always annoys me when I resize something and it just takes forever to update. It is not very nice. So I thought that could be a good place to start looking. So of course now it's running inside callgrind, but I'm not instrumenting yet, so I can use callgrind control -I on to turn on instrumentation. So now the web content process is collecting profile data. I do a resize, and of course it takes a lot longer while we're instrumenting. But once it updates, then we can go ahead and turn off instrumentation, and then we'll have captured like just the time while we were doing the resize and update. I wonder if, I was just going to check if it's still busy after that, but no, it's stopped processing. So let's turn off instrumentation and then I can quit out. Okay, so let's take a look at this thing. We'll start in the left column here where we see time being spent inclusive. So 100% below Q event loop exec makes sense. Everything's happening within the event loop. The first thing in libweb or libjs that stands out is style computer compute style with 48%. So roughly half of all time is spent just computing style. It was pretty common after resize. Then we have to recompute style for the whole page because the size of the viewport has changed. So different media queries will apply and different style may apply to different elements. So then we're seeing an update layout. Here's a JS function callback. Just ends up in update layout, sure. Okay, blah, blah, blah. Style computer, again, collecting all the matching CSS rules. Selector engine. Okay, so raw selector engine work is about 39% or so. So that is very good information. So almost 40% of runtime is selector matching. Who's this fella? Deprecated fly string. All right. Constructing a deprecated fly string from a string view. We are doing that a million times in that resize I did. And it's about 22% of runtime in selector engine matches. Okay, so that is definitely suspicious. That's work that we should not have to do while matching selectors. Like, selector matching should operate on already existing strings. Like, it should never be necessary to create a new string during selector matching. What else do we got? Run the resize steps, blah, blah, blah. Painting. Painting doesn't look terribly slow here. It seems it's really more this fella that is, because the selector matching was like 39% and 22.5% of that, or 22.5% of the total time is creating deprecated fly string from string view. So we need to track down what the heck that is. I see that K Crash Grind is struggling a little bit here with the dark theme. Apparently, it seems like maybe they have like hard-coded colors for the source code view here. I'd like to know where is, or who's calling this? Selector engine matches. Okay, so I'm just going to look for a high number here in the margin, because that's like time spent on this line of source code. So let's scroll through here. What was that? 17.52. Okay, so here is a call to deprecated fly string constructor when we are matching class selectors. Okay, so we can go look at that in the selector engine. So it's line 356. Okay. So we are trying to match a class selector against an element, and then we ask the element, hey, do you have class component.name.bytes as string view? And here is the whole problem. So instead of asking the element if it has a class and then passing it a fly string, we're passing in a string view and forcing it to construct a new fly string from that, which means that it has to look it up in the global fly string table or potentially allocate. Yeah, so we can see here that there's the hash lookup in the global fly string table, and sometimes it has to create a new string and allocate. And we shouldn't need to do any of that. So why can't we just pass the name through? Cool, because one is fly string and the other is deprecated fly string. Nice. So I think what we're seeing here is a mismatch. So if you were watching my channel, I had a video late last year about introducing a new string class. So that work is ongoing, and it seems like here we are suffering a bad performance outcome because some code in the web engine is using the deprecated old string and some code is using the new string. And it seems like the selector component here is using the new string, and the element knows it, the class stored in the element is a deprecated fly string, so the old style string. Cool. So I guess the way out of this is to, like, the nice way out of this would be to, well, I guess to update the code and element so that it also uses the new style strings. And then we would be able to pass the fly string here that we already have, the modern string, pass it through, no allocation or lookup necessary. Okay. So what if I just did that? Has class. I mean, I'm not going to get away with this, am I? M classes. Maybe I will be able to get away with this. Let's find out. M classes. All right. Back to our fly string. I'm sure that something will break here, but we'll see. Oh shoot, why are these not? Okay, let me try to open up SerenityOS instead. I have both Ladybird and SerenityOS projects in CLion, and I forget how to set it up so that Ladybird can find these in the right place. I just need to add the directory somewhere, somehow. But let me go in the SerenityOS thing, and I think it picks them up correctly. I just can't see the Ladybird Qt specific stuff. Okay, so M classes. Okay, so we got a bunch of little issues here that we need to fix. Has class takes a fly string, sure. Wait, what's wrong with that? Passing argument, no viable conversion. Oh. Okay, well, we'll come back to that one. Hold on. Has class. Okay, so case sensitivity. The new fly string doesn't have equals ignoring case. Okay, does the new string have that? It seems like it does. Okay, so we should probably port or just bring that functionality over to fly string as well. The new fly string. It's a little iffy because I think it does a Unicode respecting case compare, or caseless compare rather. So you need to link libunicode into your application, but that's okay. So let's see, equals ignoring case, and then what do we, I guess we could ask for the other thing to be a fly string as well. We might end up wanting like more variants of this API, like a couple of overloads, but right now, I think I only care about that specific one. Error or bool. And equals ignoring case is going to return an error in what case exactly? Try to case fold. Oh my goodness, it makes a new string. How great. That is unfortunate. So can we avoid this somehow? Like, do we know that these things can be, I think, is it that like an ASCII only case compare? Where do I go for that? What WG multi-page class attribute ASCII case sensitive something something. Case sensitive attribute selector blah blah blah. Our HTML classes ASCII or Unicode case sensitive. I don't know what the exact name for that is. Our class names case sensitive. I don't think we were honoring that before. I mean, that doesn't mean that we shouldn't do it correctly. I'm just wondering. Equals ignoring case took a string view. So previously it was just caring about ASCII. HTML class name are case sensitive. See the attribute definition. Okay. All selector syntax is case insensitive within the ASCII range. Case insensitive in the ASCII range says where. Let's see, ASCII case sensitivity of selectors. Selectors leaves the case sensitivity of element names, attribute names, and attribute values to be defined by the host language. Sure. Classes. Limited quirks mode. Let's see. Identical to each other. Where do we find this information? Let's see. Selectors spec. Class. Case sensitivity. All selector syntax is ASCII case insensitive. I'm pretty sure that it just needs to be ASCII case insensitive. So I think what I really want, like if I'm wrong about this, I'll have to, we'll have to fix that obviously. But I think we should have like a special function that does a ASCII only case insensitive compare. Equals ignoring case ASCII. Or equals ignoring ASCII case, let's say. And that doesn't need to allocate, so it doesn't need error or return type. And then we'll make that no discard, so you don't do work for no reason. Compare this fly string against another string with ASCII only. Yeah, it doesn't require a libunicode. Let's have this API. And let's just add it here. Okay. And then if I am the other string, then return true, of course. Oh, wait, no, that's not how you do that. I want to do this. Because equality comparing a fly string to another fly string, that's just a pointer compare under the hood, because fly strings are, they're unique within the program. So that should be fine. But if they're not identical, then they could still be ASCII case insensitive identical. So at that point, we need to return string utils equals ignoring case, which should potentially be renamed to equals ignoring ASCII case. Bytes as string view, other bytes as string view. Right. Let's see, is that fine? Is this the right way to do this? Feels a little bit rickety. If I am a UTF-8 string, then I only want to look at the actual ASCII characters, I guess. Yeah, okay. Well, we'll come back to that. Okay, so imagine that we have that API, which will take a hot minute to rebuild. Well, maybe it's not that bad, actually. Although I should limit it a little bit while I'm recording. Equals ignoring ASCII case, like that. We're good, okay. Here, M classes append new class. Okay, so here we will have to make a new fly string. Can we make it from UTF-8? Yes, we can. And we should fix me for error propagation there, right? Okay, so I think we can get away with that right now. So basically, attributes, DOM element attributes in libweb right now are stored as deprecated strings or deprecated fly strings. At least the attribute names, not the values. Yeah, the names are deprecated fly string. The values are deprecated string. Right, okay. So for the classes, we extract all of the class tokens from the class attribute. So if you say like this in HTML, right? Some element, some div, then we will take this string here. This is the value for the class attribute. And we will split it into these 3 tokens and then insert those into the class's vector. Okay, that shouldn't be that tricksy, actually. Okay, and then what do we have here? List of class names. And that is a vector that we're constructing it here by splitting. So we can just split with creating these instead. And of course, we end up having to put this because there's no error propagation path at the moment. That is, it's not ideal, but it's okay. I'm probably going to hit more cases. DOM document CPP. See what's going on there. Okay, get elements by class name. Again, it splits the incoming string here, splits it by white space, and then creates a vector of class names. So we have to do that ourselves. Fly string from UTF-8 and so on and so forth. That's fine. And then we can search using that string. I have to admit, when I saw where this was going with like the deprecated string versus regular string, I thought this might be a huge thing that would take like 2 hours to do all the necessary cleanup to make this work. But it's starting to seem pretty contained because every element, because we have to access the list of individual class names so often during selector matching, we cache each class in this thing here, and this is in the element class. So every element has a list of its classes, right? So we can very quickly look up all of the classes that an element has. If we didn't have this, and we would instead have to go to the attribute, and the attribute would be deprecated string, and that might be like a bigger thing to untangle. But it seems like maybe we'll get away with a pretty small change here. And I think we're also discovering that it's probably healthy to have like ASCII, when it comes to like caseless compare functionality on string classes, it's probably good to have sort of an ASCII only escape hatch, because a lot of protocol specifications and stuff like HTML and CSS and JavaScript, they do restrict themselves to ASCII only text in many cases and places. So having a way to say, oh, I only care about ASCII case sensitivity means that you can do much more efficient string comparison routines. The full Unicode caseless compare is fairly complicated, and I don't think you have to allocate a new string like we do, but it's certainly one way that you can implement it. So you case fold both of them. And I think you can do sort of a streaming compare where you look sort of streaming case fold both strings, but that is something we haven't implemented. Okay, so that built. Let's see if we can run that again. And of course, we are still running in Valgrind here with the call grind tool, so that will slow us down a bit, but I'm hoping that we should be able to see that this thing was just nuked from the profile entirely, because we should no longer be creating these. They would be created like when we parse HTML. So when we parse the attribute, then we create the fly strings for each class. And then during selector matching, all we have to do is just do the compare, which, as I mentioned, is just a pointer compare because they are globally unique strings. Okay, so let's turn on instrumentation. Let's do a little resize like that. And now we are recording, hopefully some very interesting data. We'll see. Okay. And exit. 82286. Deprecate. And look at that, you moved all the way to the bottom. So if we're looking at the top here, what was it previously in the previous run? It was at 22.57%. And now it's gone. That is frickin' nice. I love it. All right. Now, compute style is 26%. In the previous run, compute style was 48%. So that's down dramatically as well, right? And that's just a result of style selector matching, no longer having to create all those strings. But that's fantastic. And now what starts to stick out, I guess we should look around. I mean, I need to make commits for what we were doing. I'm just kind of curious what's up next. Anti-aliasing painter fill path. I think probably that's what's calling set pixel. Yeah. So we have about 20% of time spent in path filling now, which would be in an SVG. We probably have the background of the Discord page, or Discord uses a ton of SVGs, and 20% of our runtime now is filling SVG paths. So that definitely room for optimization there. We still spend a fair amount of time selector matching, like 16% in collect matching rules. So there's probably more we can do there. But wait, 15% in create pseudo element if needed. That's quite a bit. Like, I wouldn't expect the page to have that many pseudo elements that it would take up 15% of runtime. Pseudo elements are like, we don't even support that many pseudo elements, like the before and after pseudo elements we support. And maybe that's it. So why, or maybe one more, I forget. Which ones do we support? Or which ones do we actually use, rather? Create pseudo element if needed. I guess that's what I should be searching for. Okay, so we're making the before, after, and those are the only two ones we create. That's so weird. Why is that taking 15% of runtime to try to create those? Where's time go? Compute style. So most of it is selector matching, it seems like. I mean, I guess you have to still match selectors to make the pseudo elements. Although we have an optimization for that. Like we put all the CSS rules into these buckets, and I'm pretty sure I added a bucket for pseudo elements. Collect matching rules, so that when you're matching pseudo elements, then you should, wait, where am I even? Collect matching. This is HTML collection, that's not what I wanted. I wanted the style computer. Collect matching rules, sorry. Let's see here, rules by pseudo element. So if we are collecting style, matching style for a pseudo element, we would be called with some pseudo element. So we call this function with like the type of pseudo element we're trying to identify. Like, should this element have a before pseudo or an after pseudo? So we call this thing, and if we're asking about a pseudo, then we will only evaluate the rules that we know have a pseudo element selector in them, and we don't evaluate the other rules. So I would expect it to be fairly tight, because like, unless the whole style sheet has a bunch of pseudo element rules. Well, actually, we only do this if the cascade origin is author. What if it isn't? If it isn't author, then we just run every selector. Oh, shoot. So we're not doing any of the bucketing optimization for non-author styles. And that means that like the built-in CSS that comes with the browser engine, that is not that's not author origin, but that's user agent origin. So if you look at cascade origin here, that would be user agent origin, which means that everything in the default CSS file, so this thing that we ship with the browser, all of these selectors will be run against every element when we're asking if it has any relevant pseudo element style. We don't have to do that. Is there any pseudo element in here? WebKit progress bar. Wait, shoot, do we support that somehow? WebKit progress bar. Oh man, we turned it into pseudo element progress bar. Say what? Oh man, I remember this. So that is set up here. Okay, so we do actually care about a couple other pseudo elements. We do pseudo element progress bar and pseudo element progress value. Cool. Progress bar, progress value. Okay, so we do set up those pseudo elements as well. So we have to care about pseudo elements in the default style sheet. Do you have anything else other than those? Placeholder. Ooh, look at that. Placeholder. That's so cool. Backdrop. Sick. Cue before and after. Okay, so there's like a little bit of this and that. A little mixed bag of pseudo elements here. So I think we probably just want to do the same exact optimization we do for author style. And we want to do the same thing for user agent style so that we just bucket these and then we can run only the relevant ones. And that should allow us to run like however many there were here, like 5 selectors or whatever from the default style sheet. Every time you're asking about pseudo elements, instead of running, I don't know, it's probably like hundreds of selectors in here. Probably run those for every element for before and after pseudos. So I could imagine that there's a couple hundred selectors that we would run for every element here that we could avoid, which would probably make a dent in this thing. Okay, what before I get super ahead of myself here, let me make commits with the stuff I was just doing. So I guess we'll wait, that's not at all what I wanted to put. I wanted to add the API equals ignoring ASCII case, and yeah, I'm gonna put a little fix me in that one. Fix me. Maybe rename string utils equals ignoring case to equals ignoring ASCII case. Fix me. Make this function. Make sure this function behaves correctly with non-ASCII characters in the presence of non-ASCII characters. Yeah, I'm going to say, instead of maybe rename, I'm just going to put rename. But if I rename that, I have to rebuild the entire world. So I am leaving that as an exercise for the fix me reader. Okay, so add fly string equals ignoring ASCII case. Okay, and then we had a bunch of libweb changes. Maybe we will do the, I guess all of these are part of the same thing. Yeah, they're all part of the same thing. Libweb, use fly string, convert DOM element M classes from deprecated to new ACK fly string. This makes selector matching significantly faster, even though it's like we're doing something that we originally didn't do, and then we started doing because the conversion was at a halfway point, and now we're like back to the performance we had before, basically. But by not forcing us to convert from deprecated fly string to fly string matching class selectors. Cool, and then the remaining stuff is just my hack to run in call grind. Okay, so what was I saying that we should do? We should try to do the pseudo element thing. Right. So how is that structured? So here, when we collect the matching rules, we're saying this because I think we only build these smart rule caches for author styles. And maybe we should just have like a rule cache per origin. I think that would be fine. And then this code path here wouldn't exist. We could always take the smart path that uses the rule cache. If you look at the rule cache, by the way, it's just this. It's like it has divided the various rules in the style sheet into buckets. So here is rules sorted by ID. So and here you would find like any rule where it says like, oh, the element has to have ID foo, then we'll put it under foo in the rules by ID bucket. And then we know that when we see an element that has ID foo, then we have to run that rule against it because it might match. And if it doesn't have, well, anyway, the interesting one was this one in this case, the rules by pseudo element, which is, we put in here. So for example, if you're looking for any rule that concerns the before pseudo element, then it will be here under the pseudo element before, in the before bucket. We have a vector of rules that we have to look at. Okay, so rule cache. Right now we have one rule cache. What if we just did this? Author rule cache and user agent rule cache. Imagine that. And then we would say like rule cache. Is going to be if the cascade origin is cascade origin author, then it will be the author rule cache. Otherwise, it will be the user agent rule cache, because we have other origins, but we don't do anything with them yet. Although, let me make a helper for this so we can have a healthy assertion or something. Let's see, invalidate rule cache. We'll put it right here. Where's the rule cache thing? Oh, it's further down. Let me put it here then. Rule cache for cascade origin. Okay, this will be nice. Okay, and then we'll put that right here. This should actually make selector matching faster in general everywhere, because we will avoid checking built-in CSS rules that don't apply to the current element, that are known to be guaranteed not to apply. Okay, and then I guess switch cascade origin. Return the author rule cache. Chook. User agent, and default here we'll just verify not reached, or to do. Like if we add those, then we should add a rule cache for them as well. Okay, and now we can just do this. Rule cache for cascade origin. All right. Wait, why don't you like that? Function is not marked Kunst. All right. I'll make you const. Don't have to be that way. I think it's fine for these to be const actually, because at this point we're not mutating the rule cache, we're just reading from it. Okay. And then it's just a matter of updating all of these little fellas to say rule cache dot. I almost did that right. There we go. Why don't you work? Oh, wait, I'm in a different function. I escaped the function I was supposed to be in. Oops. Okay, I went too far, and let's start that over. So I just want to change these, as long as I'm in collect matching rules. Rule cache dot. All right. So are we good? Almost. Now we need to fix the build rule cache if needed stuff. So we'll build all the rule caches at the same time. But I guess we can check for safety like that. Okay. And look, we're gonna fix a fix me. It says we should make a rule cache for user agent style as well. Who wrote that? I bet that was me. That was me. That was a while ago. Wow. Cache CSS rules and buckets to reduce number of rules checked. That was a hot minute ago. Is that February 10th? I'm not even sure what date format that is. Anyway, it was last year. So about a year ago, probably. Let's see. So I guess here I need to put this into a helper. And then say like user agent rule cache, or we'll start with the author rule cache. Should be make rule cache cascade origin author, and then same thing for the user agent. Agent, clickety click, and all of this gunk here is going to go into that little helper, which is going to be here. So make rule caching. It will take a cascade origin and return an onPutter rule cache. Click. Actually, I can return a non-null onPutter. Okay. Like that, and then we just have to return it at the end here. So return rule cache. Sweet. All right, and then here invalidate rule cache needs to nuke. Technically, we probably don't have to nuke the user agent rule cache. As long as we don't put stuff like media queries in there, we might not need to nuke it. Well, it's not terribly important right now anyway, so I'll put a note here. Might not be necessary to clear the, or to destroy the, throw away the UA rule cache. If we are sure that it's safe, we could keep it as an optimization. Yeah, we would need to be sure that it's safe though. I'm not 100% confident in this moment that it would be safe, but it seems like it would be. And oh, and this thing, cascade origin, the parameter is not used because it's hard-coded here that it only walks the author style. So we'll just pass in the parameter. And I think we'll be good. Wouldn't it be rad if that just worked? Okay, there's a bunch of stuff to rebuild, so let me just limit that a little bit. Right, so the effect of this, I'm hoping, will be to reduce the amount of time spent in, time spent in selector matching in general, because now we should spend less time matching user agent selectors. Because it doesn't only care about IDs, it also cares about tags. So it has a tag bucket, and the user agent style sheet is pretty tag oriented. So you have like a lot of these selectors that are just like dir, menu, ol, ul. And when using the rule cache, it means that we will, like if a selector looks like this, we will only run it if the element we're matching against is a dir element. So we'll skip over a lot of these selectors, which would be good because they won't be in the buckets. Bokey. I guess while it's building, we can look at how that actually works. So collect matching rules. Here, you can see what we do. So when we are choosing, actually we need to change this code here. When we're choosing which rules to run, we're looking up the tag name of the current element. There's an unfortunate string allocation here actually. But yeah, we're looking up, that will go away eventually when it's converted. The element local name would be converted to fly string as well. We look up any rules that apply to that tag name, and then we say, oh, those are rules that we must run. So we put them in the rules to run list. Right, we needed to change this code a bit because now we have a rule cache and we no longer care about the cascade origin. And we can get rid of this generic code path right here that checks every rule. Cool. To restart the builder to make sure we get all the right stuff. But this should be good. I don't know how good this is going to be, like how much it will help, but I imagine that we'll do a dent, make some kind of dent. Thankfully, we have a number here, even if it's just a relative percentage number, so we can see if it removes some of that. And then there's still a lot of things we can do to make style and selector matching much faster in general and do less of it and so on. But little by little, we gotta do one thing at a time. Ladybird, discord.com/login. Let's see if it still works. Seems to be okay so far. Some of these loads take a while. One thing that's definitely slows things down when you're running in Valgrind on Linux, like I'm doing now, is that we're not using our own HTTP and TLS stack, but we're using an in-process queued stack. So we don't get the benefits of like an out-of-process networking. So all the networking also runs through Valgrind when I'm doing this. That definitely doesn't help with performance. Let's see. All right, so I'll turn that on. Do a big juicy resize. And I'll just wait for it to react. Okay. There we are. All right. And then k cache grind, call grind 836407. So where are the pseudo elements? Create pseudo element if needed, 10.5%. Okay, so not completely gone, but we made a dent. That's good. Create pseudo element if needed. Wait, that was the first run. I don't want to mix these up now. So where did you go? Dun, dun, dun. It was 15 something, right? Here. Yeah. So in the previous run, it was about 15%, and it had about 4,600 calls. This last run, it was 10.5%, and it actually had more calls, so 5,800 calls. So we did more calls to the function, and it still ended up taking less of the total time. Seems like we painted twice. Yeah, we had that intermediate stage there where the login UI wasn't painted for some reason. Maybe if we turn off relative, we can see samples here instead. Yes, we had about 500 million samples in the first one across 4,600 calls. And in the latest run, we had 459 million across 5,800 calls. So definitely less work, less time spent, less work. And how on earth did I detach this from my window? I didn't mean to do that. Damn it. Oh, okay, there you go. Cool. That is great. Wait, what happened here? Where did the name go? I am confused. Why are the functions like, oh, maybe they're just, oh, I just changed the order. Okay, being a computer boomer here right now. So this is fantastic though. It's another solid optimization with great foundational motivation, just implementing an already existing optimization for the author style sheets and just taking that and bringing that to the user agent style sheet as well. Which there was even a fix me for it. So it's just totally good thing to do. Okay, so we'll say here, libweb, implement the CSS rule cache optimization for UA style as well. We're already sorting the author styles into author style selectors into buckets. Doing it for now we do it for the built-in UA style as well. This reduces this. Yeah, I mean, there was already a fix me about it, and this just does less work. This means less work. Less work for this selector engine everywhere. Basically. Yeah, everywhere. On every website, you get to do less work in the selector engine. So cool. But of course, there's still a lot of things to do, and I think I'm going to leave some for next time. But we took out the big, ugly, deprecated fly string constructor that was completely yeeted, and then we made a nice dent in the pseudo element and like just general selector matching with a nice optimization that will apply to every web page everywhere. So that's really good. And then I'm going to ignore the rest and wrap up the video. So maybe the last thing we'll do is just rebuild without Valgrind stuff and just see on the off chance that it's like very visually noticeable, which I don't necessarily expect it to be, but you never know. Okay, well, I'm gonna say anecdotally that it feels better. Definitely not perfect. Also, there seems to, like, we're drawing a weird state and then redrawing again with a better state sometimes, like when I'm resizing the window. Wonder what the heck that is. It looks really dumb. It's like it draws everything far to the right when I grow the window and then snaps it and draws it again over on the left side somehow. Anyway, but let's end the video here, and I'll just say that it's good to be back looking at this. And of course, now we were only looking at the outside. We're going to continue with the login process and so on. It should be working these days, but there's a tons of bugs when you actually log in, stuff that doesn't work, and we'll look at those things. But for now, I'm just glad to be back looking at this page and making some progress on things, making things better. So that's the end of the video. Hope you saw something interesting here today. Thanks for hanging out, and I guess I'll see you next time. Bye.